Your new you. All right. On the actual test, you are getting none of this. You bring in what you want to bring in. Remember? I mean, now I'm not giving you any of this. That would be very smart. What did he just say?
I heard what he said. I didn't bring your answer.
I said that would be very smart. Matter of fact, you want to just take this page and let that be your page and then write stuff on it. That'd be pretty smart too. I'm just saying. No, you have a page, one page, which like I'm starting to have doubts about at this point. So I wouldn't push it. That's all I'm saying. All right. Woo. Simplify and use a Pythagorean identity to verify the following. This one's not that hard at all. It just looks scary. And that's the key to the test, guys, is I try to make them look scarier than they actually are. But you got to think about what's going on in the problem. All right, so we got cosine times secant. Cosine times secant is 1. They're reciprocals. All right, cotangent, and you got sine squared. Well, think about it. Cotangent is cosine squared over sine squared, right? And you have sine squared. So what's going to happen to those two sine squareds? They cancel. Is this true? Yep. So you're done. I see how simple that is. Deceptively simple. That's the key to this test. Deceptively simple. All right. Factor using the Pythagorean identity to verify sine tan squared x plus sine x equals secant x tan x. First thing I'm going to do in this situation is, since I see that there is a sign here and a sign here, I'm probably going to have to factor sine out. And yes, guys, I am going to move kind of fast through this thing, so make sure that you're following along. Tan squared plus 1 is equal to secant x tan x. I'm going to give you a minute and see if you can figure out where I'm going to go next. Yep. Yep. Exactly what I would do next. Unit with sine x, secant squared x. So the question then is, okay, how do I get from here to here? Well, it's actually not that hard. Remember, secant is 1 over cosine. So if you think about it, it's 1 over cosine squared. So like, or cosine squared, you can think about it like that. And then you got sine x right here. If I rearrange this part, I can arrange it like this. It makes sense? You got 2 cosines in the denominator. I could just rearrange it like this. What's this piece right here? Tangent. What's this piece right here? Once again, deceptively simple. That's the key to this test, particularly verifying identities. That's it. Like I said, these aren't hard. You just gotta think about it.
Sine x, secant squared x.
Yeah.
Secant squared, secant x, and I divided by secant. Sine x, secant x equals.
Yeah, that verifies too. For those of you who didn't quite understand what was going on, I'll show it to you. Basically, he took the same, I'm gonna use a kind of a blank sheet here. Basically, he took the idea, he had sine x, secant squared x equals secant x tan x. And he said, hey, if I divide secant by both sides, I'd have sine x secant x equals tan x, which would be absolutely correct. And then you can think about this as 1 over cosine x. And obviously sine x over cosine x is tangent. So that'll work too. Once again, there are multiple ways. I will accept whatever way you pick, just as long as it makes sense. You're using identities to go to work through it. I'm gonna tell you guys, you're gonna see Pythagorean identities a lot. You should know those like the back of your hand at this point. All right. All right, cosecant of theta is equal to this. Use cofunction even odd reciprocal identities to find cosine of theta minus 90 degrees. All right. The first thing is with these, the 90 and the so basically we're trying to deal with this cofunction identity. And our cofunction identity states, I've written all over it, but basically we've got that sine theta equals cosine of pi over 2 minus theta. So what we want to do, and remember pi over 2 is the same thing as 90, so basically this is cosine of 90 minus theta. So the first thing that we have to do is use the fact that cosine of theta minus 90 is the same thing as cosine of negative 90 minus theta. All right, that's just some algebra, just factoring a negative out. Now, why in the world would I do that? Well, because if you'll remember, cosine of negative theta is actually the same thing as cosine of theta. And therefore, if cosine of negative this thing, right, is this, then technically I can remove the negative and I get just my theta. So in this case, we can see that cosine is going to be also equal to 90 minus theta. Now, the reason why we have to do this step is because we want this to be now what? Sine. So no, the only thing we've done at this point is just shown or proven that sine theta is equal to cosine of theta minus 90 degrees. Now, do you have to do this whole part for the problem? Not actually, because remember the question's asking, we want to find what this is. Well, if you want to, what you could say is cosine of theta minus 90 degrees equals sine of theta. So now all we got to do is figure out what sine of theta is. Well, if cosecant of theta is this, right? Then we know that sine theta would be 1 over that. Right, it's a reciprocal identity. And you could compute what the answer is, but at this point, I would accept this. And that's it. This top part, that's all we need. I wanted to prove this was true out here, but this part is really the only thing you needed for this problem. Do you see how I use the cofunction identity here? Well, I use the even odd identity here, cofunction identity here, and I use the reciprocal identity for the last part. So where it says use cofunction, even odd, and reciprocal, you can do that. It doesn't have to be in a logical pattern, not necessarily, but if you can bring it back together in the end, it'll help me a lot. Does that kind of make sense? Okay. Let's take a look at number 4. Sine of A is 2 over 4. Cosine of B is this. Find and rationalize the exact value of sine A plus B. All right. So the first thing we're going to do with this problem is we're going to look at A and we're going to look at B. Now, the biggest thing that people want to do is assume that A and B are on the same triangle. That's not necessarily true. Okay. It's not necessarily true. So let's walk through this. We got A. We've got B. We know sine of A is 2 over 4. And we know cosine of B is -3. Or -3 should be here over 5. Okay. So that said, we can figure out what these two are supposed to be just through the Pythagorean theorem. So I'll call this X, I'll call this Y. So over here, I'll say that 2 squared plus X squared equals 4 squared, which gives me 4 plus X squared is equal to 16. So therefore, X squared is equal to 12. And therefore, X is equal to 2 root 3. You can go back and check my math on that, but it is correct. Also, this is a 30, 60, 90 triangle. So this is definitely going to be 2 root 3. All right. So we're done with that part. Now we need to figure out what Y is. And I'm pretty sure everybody can guess what Y is going to end up being. And Y will end up being what? 4, right? Exactly. Because, I mean, it's a 3, 4, 5 triangle. Y equals 4 in this case. All right. Why is all that important? Right. So we got sine of A. We already know what that is. It's 2 over 4. Let's figure out what cosine A is. Well, that would be 2 root 3 over 4. We don't know what sine of B is, but we can figure it out now. It would be 4 over 5. And cosine of B is -3 over 5. Now, why do we do all of that work? Because all we need to do now is plug it into our sine A minus B formula, which I don't want to, I'm running out of space, so let me do this. So we have sine of A plus B is equal to sine A cosine B plus cosine of A sine of B. I think I'm doing that right. Probably should just check the identity, but I'm pretty sure I'm right on that. Yeah, I'm right. All right, so then all you got to do now is take these, plug them in. So you went with 2 over 4. which you could reduce to 1/2, but it doesn't really matter right now. And then we've got -3 over 5. This is what happens when you're talking and trying to do math at the same time. Cosine A is 2√3 over 4 times sine B is 4/5. Yeah. All right. So that's a mess, but we're going to clean it up. So we got 2 times -3 in the numerator, you get -6 over 20. Plus 2 times 4 is 8, so 8√3 over 20. And yes, I didn't cancel anything just because we're going to put it all together. And so this right here would be -6 plus 8√3 over 20. Can I reduce this thing? Yes, I can. It'll end up being -3 plus 4√3 over. You're done. So it did take a while, but I think you all can agree it's not really that bad. You just got to think about A, B, and figuring out all the sine, cosine, all that junk, and then plugging it in is your last part to that. All right, so let's move right along. Cosine of theta is 2/3 on the interval. And this interval, find and rationalize the exact value of tangent of 2 theta. All right. So let's think about this. It's between 90 and 180. Well, technically, cosine is 2/3 on this interval. It really should be cosine theta equals -2/3. So let's make that negative here. Why is that the case? Because we're on the interval from 90 degrees to 180. Therefore, cosines here are all negative, right? So technically it should be -2/3. That's fine. Anyway. So what does that have to do with anything? Well, let's think about it for just 1 second. If cosine of theta is equal to -2/3, what is tangent of theta? Well, tangent of theta, as we know, is opposite over adjacent, right? Or more importantly, tangent of theta is y over x. So if cosine of theta is -2/3, and we'll draw a little triangle and kind of thinking about it. But this is -2 and this is 3. Because our radius is thirds. We try to figure out what this is. Then what we can do, or as a matter of fact, we should call this y. What we can do is we can say, all right, I got y squared plus -2 squared is equal to 3 squared. Well, y squared, just y squared, plus 4 is equal to 9. So y squared is equal to 5. Therefore, y equals square root of 5. So if y is the square root of 5 and x is -2, then I know that tangent is going to be √5 over 2. Now, why do I need that? Because if I'm going to use tangent of 2 theta, which we need the formula for that. Tangent of 2 theta is, let me see if I remember it correctly. I think it's 2 tan theta over 1 minus tangent squared theta, I think. Okay. And so if you do 2 tan theta, all we got to do is wherever tan theta was, we're going to replace it with √5 over 2. Okay. We're replacing it with √5 over 2. So you end up with 2 times √5 over 2 over 1 minus √5 over 2 squared. Well, in the numerator, the square roots cancel. I feel like it's getting a little too muddy. So let me get some more perspective here. Matter of fact, let me use a totally different color. So I'm just going to rewrite that last part because it's like kind of hard to see. So root 5 over 2, numerator over minus root 5 over 2 squared. All right, so basically what we've got here, what we're going to do here is the 2's cancel. You're just left with root 5 in the numerator. In the denominator, you got 5 over 4. So you have 1 minus 5 over 4. This is square root of 5. If you have 1 minus 5 over 4, that's going to be 4 over 4 minus 5 over 4, so negative 1/4. So you basically end up with a square root of 5 over negative 1/4, which if you think about this for a second, you can realize that if you use keep, change, flip, you'll flip the denominator and you'll end up with negative 4 root 5. No, wait. Wait. It should be positive 4 root 5, and I'm going to explain why. It's going to be positive 4 root 5 because back up here when we did tangent of theta, it should be negative. It should be negative tangent because this was negative 2 and this was root 5. So it makes that negative, which makes tangent should be negative because we're between 90 and 180. Remember, because x is negative, y is positive. You put those together, it should be a negative. The only thing that changes is that makes this negative, which makes this negative, which makes this negative, which makes this positive. So just be very careful about that part, that side of it. And make sure you keep your signs straight. But as you can see, it didn't completely change, like the value of the problem. So like if you missed a negative or something, I would maybe take off like each problem is probably worth 10 points. I'd probably take off a point or 2. All right. Tangent is equal to 2/3 on the interval 0 to 90. Find the and rationalize the exact value of sine of 2 theta. All right. So the first thing I'm going to write out is the actual, which is what I should have done the last time. Sine 2 theta is equal to 2 sine theta cosine theta, right? And so what we're going to do is we need sine theta and we need cosine theta. Now this should be easiest, right? Because it's on this interval from 0 to 90, which means everything's positive. Yay for us. And so tangent of theta is 2/3. You can kind of think about it like this. If tan theta is 2/3, then that means we have a situation where your x values, your y value is 2, your x value is 3, right? Now, all we got to do is figure out what this r is. And that's easy enough to find because r squared is equal to x squared plus y squared. Straight Pythagorean theorem. And, the equations of circles as well. And so we got r squared is equal to x squared plus y squared. What we're going to do is plug everything in. You end up with r squared is equal to 2 squared plus 3 squared, which is 4 plus 9, which is 13. So r is equal to root 13. And so now what we can say is sine theta is going to be, let's see, 2 over root 13. And cosine theta is 3 over root 13. And honestly, for this problem, you don't even need to worry about rationalizing the denominators because you're going to eventually multiply them together anyway. Okay. So then you're going to multiply, this by 2 basically. And if you do all that together, you got 2 times 2, which is 4 times 3, which is 12. Root 13 times root 13 is just 13. And sine of 2 theta equals that. Everybody cool with that? Feel good? All right. It's only a few more. If cosine of theta is equal to 2/3 on the interval of this thing, find and rationalize the exact value of cosine of theta over 2. So this is a half angle one. Let's see. I'm cutting 7. Cut 7. I don't want to deal with half angle problems. I mean, literally, it just get weird. And it's really, you rarely see them. I mean, when you say rarely see them, I mean, you rarely see them. All right, let's deal with this one. Now, find all solutions for 3 secant x minus 2 secant x plus square root of 2 on the interval from 0 to 2 theta, or 2 pi, 0 pi to 2 pi. This one should not be too hard. Basically, first thing we're going to do is we're going to subtract 2 secant x from both sides. When we do that, you end up with secant of x is equal to root 2. Therefore, cosine of x is equal to 1 over root 2, which if you rationalize the denominator, you all should know where this is headed. What's the rationalized version of this going to be? Root 2 over 2, exactly. All right, so we know there are 2 places where this occurs. Once again, you can go back, and this is kind of a messed up unit circle at this point, but you can go back to your unit circle and look for where cosine or your x value is root 2 over 2. That's here at 45 degrees or pi over 4, and down here at 7 pi over 4. So what you're going to say is then, therefore, x, and these should be thetas, but whatever, x is going to be pi over 4 or 7 pi over 4. I know I did that quickly, but we're running out of time, so I need to kind of move forward. But does that make sense? It's what we've been doing the past week, so you should kind of sort of make sense. All right, find all solutions to 4 sine squared minus 2 is equal to 1 on this interval. So once again, same idea. We got 4 sine squared x minus 2 equals 1. We want to get that sine squared by itself. So we're going to add 2 to both sides. You end up with 4 sine squared x is equal to 3. Then we're going to divide 4 on both sides, which gives us sine squared x is equal to 3/4. If we take the square root of both, you end up with sine x equals root 3 over 2. But what am I missing here? Plus or minus, because remember, we're taking a square root of something. You take the square root of something, you got to put that plus or minus on there. So that means instead of 2 places this being true, there are 4 places this is true, correct? So then we got to look at all the y values being root 3, and I think those are the pi over 3s if I'm not mistaken. Yeah, here pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3, which are all, reflections across the x and y axes. So therefore, we can say x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that's our answer. Deceptively simple. That's the key to these. Deceptively simple. Now, the first thing you're going to want to do on number 10 is divide tangent on both sides. But as we figured out last time, that's not what we want to do, right? We're just going to subtract 1 on the other side. So what I'm going to do is I'm actually going to subtract tan squared sine squared to this side. So if I subtract it over, you end up with tan x minus tangent of x sine squared of x equals 0. What do I do now? Exactly. You're going to factor the tangent out. You end up with tangent of x, 1 minus sine squared x equals 0. All right. And 1 minus sine squared x is actually cosine squared x. So what I could really do technically in this problem, if I wanted to, is I could say, okay, I've either got tangent of x equals 0 or cosine squared x equals 0. Now you could say 1 minus sine squared x equals 0, then solve, with sine squared is equal to 1. But remember, that would be the exact same thing as cosine being 0. Does that make sense? All right. Wait a minute. Nah, you don't want to do it like this. See, this is me trying to shortcut. Let's just keep it simple, right? Sine squared x is equal to 0. I just thought of, well, yeah, it would work either way. Never mind. All right, so we're going to subtract 1 on both sides. With negative sine squared, x is equal to -1. But yeah, I want to keep it simple anyway. Sine squared is equal to 1. So therefore, sine x equals to plus or minus 1. Plus or minus 1. So now if we put it all together, tangent of x is going to be equal to 0, or rather we could say tangent of theta is going to be equal to 0 when you have 0 over no matter what x value this is. So basically your y value needs to be 0. Okay. And so where's the y value going to be 0? Well, pi over 2 and 3 pi over 2. All right. So we know that at least x has got to be pi over 2 and 3. Y value equal to 0. My bad. Y value equal to 0 is going to be at 0 and 2 pi. So we got 0 and 2 pi's, or 0 and pi rather. X equals 0, pi, and pi. So that's from the tangent part. Then we got sine x is equal to plus or minus 1. That's the 3 pi over 2 and negative pi over 2. So with pi over 2, 3 pi over 2. Right, but you'll only have half the answer. Think about it. If you have 1 is equal to sine x squared, then you'll only have this part. You won't have this part. Because this is true too. What if tangent is 0? Doesn't that work as well? Yeah, it does. And that's why we have to subtract over. And the other reason why I guess, yeah, because you weren't here. What we found out last week is if you divide by tangent first, or divide by secant, or divide by sine, by taking away that other value, it could be a situation where sine squared equals x doesn't make any sense. I'll show you. I'll show you what I mean. So if you have, let's say you have secant x is equal to secant x cosine x, or you just have something like this, right? And you divide both sides by secant x, you end up with 2 is equal to cosine x, right? Well, the problem with this is undefined. Why? Because remember, cosine only bounces between 1 and -1. So cosine x equals 2 makes no sense. So then we've cut out completely where secant x could be 0 by dividing by secant x. So that's why we subtract over first and then factor out. Great question, though. All right, anybody else? I'll make sure to post the recordings. I got 11. And then 12 through 15, yes, you all have to do that. You are advanced credit, so I would work on those. But I'll try to post a recording with everything on it, okay? All right, guys. Have a good one.